Okay, hi everyone. We're looking at 7E part 2 where it's volume calculations. I just want to make a short video looking at these yellow shapes. These ones are really quite easy, quite straightforward. And what I want to make clear, the way the book talks about doing these volumes, and I agree with this, is rather than worrying too much about a separate volume formula for each shape. If I go back a page, I'll show you what I'm trying to get to. Here we go. If you know the area of one end of the shape, and then you multiply that area through the shape, right, you'll get the volume. Now, this will only work if you've got a uniform cross section through the shape, but a lot of these shapes are uniform. So that line there is parallel with this little line at the back, which is parallel with this. So this whole end, this triangle at the end, you can imagine it just kind of moves through the shape this way. And if you know the area of that triangle and you multiply it through that length, you get the volume, right? So if you know that concept, it makes working out volumes a bit easier, I think. So let's go back to those questions, because I think we can probably do all of them fairly quickly. All right. And that's going to be my approach. So imagine I had a rectangular prism. Oh, here's one. Rectangular prism. All right. So we might think about what's the area on the end of this prism here of this rectangle. And then we'll just times that by 8. Right? So I've got a rectangle on the end. Sorry about the drawing there. It's a 4 by 3. That has an area, length times width, of 12. And then you times by 8. Right? So take that, multiply it by 8, and you'll get 96. So the area, 96 meters cubed. Right, please, please, please write meters cubed. There's always someone who doesn't. But units are important in this world that we live in. So it's the same thing here. Find the area there on the square, times it through the length. There is a formula, so if I had volume of a rectangular, I'll just write rectangular prism, would equal length times width times height. And if you want to learn that formula or write it down, that's fine. That'll work. But for me, I've always got this idea in the back of my head when it comes to volumes that if I know the area of the end, it's quite easy just to remember the area of a rectangle, length times width, and then times it through the length of the shape, because then this will work for other shapes, right? For example, this triangular prism. Now they've given us the area. I know it's an area because they've shaded it and because it says meters squared, right? So I know that I have the area of the end. To work out the volume of this triangular prism, I'd need to just take that area, times it by 3.2. Right, so it's 1.73 times 3.2. You need a calculator for that, I imagine. I'll just clear this off. What did we say? I need to check the numbers now. 1.73 times 3.2, and that equals 5.536. Now, if we were doing physics, I'd say the answer should be 5.5 because there was only one decimal here. So that's as accurate as we can know our answer to be. So we'll stick to that. I might just check the question. At 5.536, so the volume is 5.5 meters cubed. What you want to be on the lookout, of course, is does the question say how many decimal places if you get decimals, right? If this was left up to me, I would only do one decimal here, even though it was 0.536, I'd leave it at 0.5 because there's only one decimal in that measurement, right? So that's as accurate as I can get with that length. I don't know what came after that too, so I'm not going to start putting extra decimals on my answer. Right? Okay, same procedure here. It looks like an odd shape, like a swimming pool, but we've been given the end, the area of the end. We would times it by 5. So the volume would be 74.6 times 5. To keep the video a bit shorter, I won't do this on the calculator. You can work out the number, centimeters cubed. I would only have one decimal place in the answer. Actually, there won't be any decimals because if you did 0.6 times 5, you'll get 3. So there won't be any decimals there. It looks like there will be decimals here. So let's do this one, E. And the screen's getting a bit messy, so I'm going to do it over here. So we've got 1E, right? We've got a triangle on the end, so right angle triangle. We want to think, what's the area of that triangle? The area of a triangle is a half times base times the height, or some people like to think of base times height divided by 2. Same thing. So here the base is 8.6, the height is 13.8. Right? To get the area of the end of this shape, this triangle, I'd have to do a half times 8.6, that'll be 4.3, times the height, 13.8. We'll find out what that is. So we've basically got 4.3 if we half 8.6 times 13.8. Times 13.8, 59.34, 59.34, try and remember that, 59.34 centimeters squared, so that's the area of the triangle. Now the length of this prism is 12.9, so therefore the volume would be 59.34 times by 12.9. Let's find out what that equals. So the volume equals, we've got a times by 12.9. Okay, so we want to get our answer, times by 12.9. 765.486. This is a good one. It's going to need some rounding, okay? So I only want one decimal place in my answer because I only started with one decimal place in the original measurements or dimensions, if you will, right? So good practice on rounding here. I'm going to write the answer as 765.5 centimeters cubed. I think that was centimeters. I'll have to double check. Yeah, centimeters. Good. All right, so I only want one decimal place. And the question is, do I keep that as a 4 or do I round it up? Right? We never round it down to a 3. It's just for that decimal place that I want to get to, that first, do I keep the number or do I round it up? And we round up because of the number after it. If that number there is 5 or greater, we're going to round up this number here. All right? So the answer is 765.5. Let's go back to the textbook. And we'll do one more very quickly. Well, you can see that was the answer for E. We'll clear the screen. And let's look at F. We've got a cylinder. How could I work out the volume? Well, I could go look up a volume formula. It would be pi r squared h, right? But another way to think about it is, well, if I know the area of a circle, and this is a really good formula to memorize because circles come up so often. If I know the area of the circle, pi r squared, all right, we've got a uniform shape here, or prism, and I can take the area of the bottom or the top, but I'm choosing the bottom because that's where they've indicated the radius, and then just multiply it by that length of 13.9, right? So let's do it over here. We'd have volume equals pi times 8.2 squared. That would be the area of the circle, and then we'll times it by the height or the length of that shape, 13.9. Let's just quickly get the answer. This might be another good one that we need to round up. So we have 8.2 squared times 13.9. So it's pi 8.2 squared times 13.9. And again, with this shape, with this volume, this answer, I need to round. There's a lot of decimals, 6 decimals there. Don't need them. It's going to look quite strange to keep them all. And when we started, we only had 1 decimal in the lengths that they gave us. So I want to go to that decimal place. Do I keep that as a 2 or do I round it up to a 3? And the answer is you keep it as a 2. And I believe these were centimetres. Make sure you put the little 3 next to your centimetres. There are some marks for writing units correctly in the real world outside of the classroom. This stuff really matters. Okay, someone needs to know if they're working in millimetres, centimetres or metres. Okay, thank you.